Hello students, welcome to Learn Guru classes. So today we are going to solve exercise 1B of RS Agarwal. So this exercise normally deals with decimal expansion. So here we are going to solve all the problems in the exercise in detail with full explanation. So let's get started. So before proceeding with the sums, you should have some understanding about the important concepts required. So there are three types of decimal expansions: terminating decimal expansion, non-terminating and repeating decimal expansion, and non-terminating and non-repeating decimal expansion. So what are all these things? So basically any fraction, let it be a fraction in the form of p by q, can be converted into its equivalent decimal expansion with the help of division. Like if I do 3 by 5, 3 by 5 is a fraction, right? So 3 by 5 if I do, so if I perform the division, so 3 is less than 5, so we are giving a 0 over here, point here, and 5, 6 are 30, so it gives the remainder as 0. So any type of division where the remainder is 0 and the decimal that is evolved from this particular fraction, so that decimal expansion is called as terminating decimal expansion, because you are getting the remainder as 0 and here the process of division is being terminated. Okay, so this is called as terminating decimal expansion. Example of terminating decimal expansion looks like 0.5, 0.625, 0.8. So in all these cases, if you see the equivalent fraction for this decimal, after in the for this fraction, the division that is being done, so here we get the remainder to be 0. Now let's come to non-terminating and repeating decimal expansion. So for this, let us take another example, that is 10 divided by 3. So this is a fraction. So if we perform the division here, so 3 3s are 9, remainder is 1 here. So we can perform the division further, but 1 is less than 3. So for that we give a 0 next to 1 and we give a decimal point. Okay, so again 3 3s are 9, again you are getting 1. So 1 is less than 3, 0. 3 3s are 9, 1, 0. 3 3s are 9, 1. So here you see that you can perform the division for a longer and longer time, but still the remainder will not come out to be 0. Means you cannot terminate the division. So for this, the name has come to be non-terminating. And why repeating? Because if you see over here, these 3 is being repeated. So for this, it is called as repeating decimal expansion. So the example of non-terminating and repeating decimal expansion like 3.3333. So that can simply be written as 3.3 bar. So this indicates that this 3 is being repeated. Another example, let us take 0.123. Okay, 0.123. 23, under 23 you are getting the bar. So what does it indicate? 1 2 3 2 3 2 3. So 2 3 occurs periodically. Okay, occurs in repetition. So for that it is called as non-terminating and repeating decimal expansion. Now if you come to non-terminating and non-repeating decimal expansion, means non-terminating means if you do the division, it will not terminate, and non-repeating means, suppose I give you an example, 0.3298697 4, 3, 1, 2. So if you see this decimal expansion, you see that no digits are being repeated in a periodic manner. So hence it is called as non-terminating and non-repeating decimal expansion. So this is one important concept that you are to remember while solving this type of sums. Now second is a rational number p by q can be expressed as a terminating decimal only when prime factors of q are 2 and 5. Now, how to identify a terminating decimal expansion without actually performing the division can be done with this rule. Okay, so suppose any fraction is in the form of p by q, where p is the numerator and q is the denominator. Now if this q, the factors of q can be expressed as 2 to the power of n into 5 to the power of n, so that is if this can be expressed, q can be expressed in this form, then we can predict that yes, it is a terminating decimal expansion. So let me give you an example like 3 by 8. So 3 by 8, if you see the factors of 8, 2 4s are 8, 2 2s are 2. Okay, so 8 can be expressed as 2 to the power of 3. So 2 to the power of 3 into 1 we can write. Again 2 to the power of 3 into 5 to the power of 0 we can write. So is this resembling this form? Yes, this is resembling this form. So we can say that 3 by 8 is will give a terminating decimal expansion. Okay, so keeping these two important concepts in mind, let us try to proceed with our exercise. The first type of sum is without actual division. Find out which of the following rational numbers are terminating decimal. So, as I have already told you that without actually perform the division, by looking at the denominator, you can, or finding out the factors of the denominator, you can say whether it is a terminating decimal or not. So, if the denominator, the factors is in the form of 2 to the power of m into 5 to the power of n, then we can say that it is a terminating decimal. So, factors of 80 are, let us see the factors of 80 by factorization: 40, 220, 210, 2 5s are 10. So, 2 to the power of 4 into 5. So, as you can see here, 2 to the power of 4 into 5, it simply resembles this form. So, we can say that 13 by 80 will give a terminating decimal. Okay, so next let us see 7 by 24. So 7 by 24, factors of 24 are, 2 to the power of 3 into 3. So, since it is not in the form of 2 to the power of m into 5 to the power of m, so 7 by 24 will give a non-terminating repeating decimal expansion. The third is 5 by 12. So, factors of 12 are 2 to the power of 2 into 3. So, here also it is not in the form of 2 to the power of m into 5 to the power of n. So, 5 by 12 will give a non-terminating and repeating decimal expansion. Okay, so the fourth sum is 31 by 375. So let's find out the factors of 375. So 5 sevens are 35, 5 sevens are 35, so 75. So 5 15, 5 threes are 15. So factors of 375 are 5 to the power of 3 into 3. So though we have powers of 5, but 3 as 3 is there and 2 is not there. So we can say that 31 by 375 will give a non-terminating and repeating decimal expansion. The fifth sum is 16 by 125. So if we find out the factors of 125, we see that 125, 525, 5 5s are 25. So factors of 125 are 5 to the power of 3. Okay, so easily 5 to the power of 3 into 2 to the power of 0 we can write, and it easily resembles this form. So we can say that 16 by 125 will give a terminating decimal expansion. The second type of sum is write each of the following in decimal form and say what kind of decimal expansion each has. So here you have to do two things. One, you have to convert the fraction into equivalent decimal form, and the second thing, you have to identify whether it is a terminating decimal expansion or a non-terminating and repeating decimal expansion. So the first example is 5 by 8. Okay, so 5 by 8. So 8 can, let's first of all identify whether it will give a terminating or a non-terminating decimal expansion. So 8 can be written as, or the factors of 8 are written as 2 to the power of 3. So 2 to the power of 3 means it is giving the form of 2 to the power of n into 5 to the power of n, which is a condition of terminating decimal expansion. So 5 by 8 will give a terminating decimal expansion. Now, what is the decimal expansion? So for that you have to perform the division. So 5 by 8. So here we write 5. So 5 is less than 8. So for that, what you need to do? You need to give a decimal in the quotient part and a 0 here. So 8 6 are 48. So here 2, again 2 is less than 8, so we will be giving a 0 here. Now no need of putting the decimal here because once you have given the decimal. Okay, so 8 2s are 16. So after that here comes 4. So again 4 is less than 8. So here you have to put 0. So 8 5s are 40. So the equivalent decimal expansion for equivalent decimal expansion of 5 by 8 is 0.625. So you can see here clearly that since it is in the form of 2 to the power of 3, here you get the remainder as 0 and thus it is a terminating decimal expansion. Now 7 by 25. So the factors of 25 are, 5 5 square simply. So 5 square again it is in the form of 2 to the power of n into 5 to the power of n. So you can write 7 by 25 will give a terminating decimal expansion. Okay, so to find out the equivalent decimal expansion, what you need to do, you need to perform the division. So 7 by 25, so here 7 by 25, so what do you do? 7 by 25, you write here 7 and here you give the decimal since 7 is less than 25. So 25 into 2 gives us 50. So 0, 2, again 20 is less than 25. So here we give a 0 here. The 25 8s are 200. So you are getting the remainder to be 0. So here equivalent decimal expansion of 7 by 25 is 0.28. The next sum is 3 by 11. So the factors of 11 are only since 11 is a prime number. So factors of 11 are, you can write 11 as 11 into 1, right? So it cannot be expressed in the form of 2 to the power of n into 5 to the power of n. So what will you write? 3 by 11 is a non-terminating repeating decimal expansion. Okay. Now 3 by 11, what is the equivalent decimal? Let us do the division. So here 3 is there. So 3 is less than 11. So you are giving here 0. 11 2s are 22. 8 0. 11 7s are 77. You are getting 3. 11 2s are 22. Here you come 30 minus 22, that is 8. 11 7s are 77 3. So you see that 2.27 you are getting, that is the sequence is 0.27 0.27. So you can simply write it as 0.27 bar. Okay. Next is 5 by 13. So factors of 13 are, again 13 is a prime number. So 13 are 13 into 1. So here also the same thing. It is not in the form of 2 to the power of n into 5 to the power of n. So 5 by 13 is a non-terminating repeating decimal expansion. Okay, so 5 by 13 can be expressed as, okay, sorry, 5 by 13. So here 13 3s are 39, 1 1 0. So 13 8s are 104, 6 0. So 13 4s are 52, 8 0. So 13 6s are 78, 2 0. 13 1s are 13, 7 0. Okay, so it's not clear here as due to the space constraint. I will do the division here. Okay, so the thing will be clear to you. So 5 by 13, 13 3s are 39, 1 1 0. 13 8s are 104, 60, 13 4s are 52, 80, 13 6s are 78, 20, 13 1s are 13, 70, 13 5s are 65, 50, again 13 3s are 39, 10, 110. So 13 8s are 104. So if you see here, a sequence is being repeated. So the equivalent decimal expansion, the equivalent decimal expansion of 5 by 13 is 0.384615. Under this, you will be giving a bar. The next sum is 11 by 24. So the factors of 24 are factors of 24 are 2 to the power of 3 into 3. Now, since it is not in the form of 2 to the power of n into 5 to the power of n, so 11 by 24 will give a non-terminating and repeating decimal expansion. Okay, now find out the equivalent decimal expansion. So 11, give here 0, decimal over here. So 24 4s are 96, 4, 10, 11, 1, 0. 24 5s are 120, 0, 2, 0. 24 8s are 192, 80. 24 3s are 72, 80. 24 3s are 72, 80. 24 3s are 72, 80. So the sequence of 3 will be repeated. So here we see that it is being repeated. So the equivalent decimal expansion is 0.458333. So you can just write it as 0.4583 bar. Since 3 is being repeated, so you are giving a bar under 3. So next sum is 261 by 400. 261 by 400. So 400, factors of 400 are, I am not doing the factorization. I hope you know the factorization. I am just writing down the factors of 400. It can be expressed as 22 to the power of 4 into 5 square. Okay, so this is in the form of 2 to the power of n into 5 to the power of n. So here you are getting 261 by 400 will give terminating decimal expansion. Now to find out the equivalent decimal expansion, we will do the division. So 261 is less than 400. We are giving a 0 over here and a decimal here. So 400 into 6 will give us 2400. So this is 0, 1, 2, 0. So 400 into 5 is 2000, so 001. Again here 0, so 400 into 2 is 800, so 002. Again 0, so 400 into 5 is 2000. So the equivalent decimal expansion is 0.6525, and here since remainder came out to be 0, so for that we are giving here as terminating decimal expansion. Next sum is 231 by 625. So 625, if you find out the factors of 625, so it can be expressed as factors of 625 are 5 to the power of 4. Okay, if you do the factorization, it will give you 5 to the power of 4. So it is in the form of 2 to the power of n into 5 to the power of n. So we can write 231 by 625 will give a terminating decimal expansion. Okay, to find out the equivalent decimal expansion, we will perform the division now. So 231 I am writing, 231 is less than 625. So here you are giving as 0, and you are getting 3. 625 into 3 will give 1875. So if you do the subtraction, it will give 5, 1, 7, 3, 4, 3, 5, 0. Okay. So 625 into 6 will give 3750. So this 0, 0, 6. Again 0. So 625 into 9 will give 5725. So this is 572. Okay, 275. So 625 into 9. 5 nines are 45, 9 is 18, 2, 54, 55, 56. So this is 56, 5625. So this is giving us 375, again 0. So 625 into 6 will give us 3750. So thus the remainder comes out to be 0. So equivalent decimal expansion is 0.3696. Okay. So next sum is 2 5 by 12. So it is coming in the form of a mixed fraction. So let us convert it into equivalent improper fraction so that it comes in the form of p by q. So the equivalent improper fraction is 29 by 12. Okay. So now the denominator is 12 here. So factors of 12 are 2 square into 3. So it is not in the form of 2 to the power of n into 5 to the power of n. So therefore 2 5 by 12 will give non-terminating and repeating decimal expansion. Okay. Now if you want to perform the division, so 29 by 12. Okay, I am performing the division here. 2 2s are 24. Okay, 5. So 5 is less than 12. So you give a decimal here. So 12 2s are 48. Again it comes out to be 12 4s are 48, it comes out to be 2. 12 1s are 12, okay, it comes out to be 8. So 12 6 are 72, again 8. So here you see that 6 is being repeated. So 2.41666. So this can be written as 2.416 bar. Okay. So equivalent decimal expansion is 2.416 bar. The third type of sum is express each of the following decimals in the form of p by q, where p, q are integers and q is not equal to 0. So here you are given with a decimal expansion and you have to convert it into p by q. Like in the previous case, you were given a fraction and you were to convert into equivalent decimal expansion. Now just the opposite. Okay, so there are certain steps behind for solving this type of sum. So I will try to explain each and every step along with the sum as we proceed with the sum. So 0.2 bar. So what does it indicate? That this 2 is repeating. Okay, so let's write let x equal to 0.2 bar. That is, you can write this as 0.2222. Okay, so to convert a decimal expansion into a fraction, what we need to do is that we need to get rid of the digits after decimal. Like if I write 2.2222, to get rid of the decimal term, I should get another term that is equivalent to minus 0.2222, so that it is 0 after decimal. So if it is 0 after decimal, it will be easier or convenient for us to convert it into a fraction. Okay, so let's see how it happens. So let x equal to 0.2 bar, that is 0.2222 we have written. So let us give it as 1, equation 1. Now one thing to note here is that after decimal, how many terms are repeated? Only one term is repeated after decimal. So to get rid of the decimal, the second step that you have to follow is that multiply this equation 1 with 10. Okay, so multiplying equation 1 with 10. So what do we get here? 10x and 10 into 0.22222. What do we get? Just these two will, once you multiply this with 10, these two will be before the decimal, leaving the other 2's behind. Okay, so that we give as equation 2. Now if I do 2 minus 1, 10x minus x, so this will be 2.2222 minus 0.2222. If you subtract this, you will be exactly getting 2, and here 9x. So x equals to 2 by 9 is the equivalent fraction for this decimal expansion. Now if it would have been 0.32 bar, so if you see here, means after decimal 2 digits are within the bar. Okay, so in this case you would have multiplied it with 100x into 32.32. Suppose 0.32 bar, you could have write it as 3 this. So 32.3232. So we'll get it in the second sum. So this is the general rule. So if the number of digits, you have to see how many digits are under the bar. So the number of digits that are under the bar, it will be multiply it with the equivalent, either 10x if one digit is under the bar, if 100x if two digits are under the bar, if 3 digits are under the bar, then 1000x, and so on. Okay, so the things will be more clear to you once we proceed to the next sum. So the next sum here is 0.53 bar. So you see here 2 digits are under the bar. So what do we do? Let x equals to 0.53 bar. So that can be written as 0.535353 and so on. Okay, so let us give this as equation 1. Now since 2 digits are under the bar, so what will you be multiplying it with? So to get rid of the decimal, so you will be multiplying both sides by 100, okay, or with 100. So this you are getting as 100x, and this here what will happen? So 2 digits will, once you multiply this with 0.535353, so here 2 digits will be after the decimal, before the decimal, and the rest will proceed in this way. Okay, so that we give as equation 2. So 2 minus 1 will give 100x minus x, 53.5353 minus 0.535353, as many 353 you write here, as many 53 you write here, it doesn't matter, because after subtraction the whole thing will come out to be 0. Yes, so this 100x minus x will give us 99x, and this will be 53. So x will give us 53 by 99. So 53 by 99 is the equivalent fraction for this decimal expansion. Okay, so the next sum 2.93. So here if you see in the previous case, what has happened, or the entire thing was within the bar, and before decimal no digit was there. But here one digit is before the decimal, so it doesn't matter hardly. You will continue with the same procedure as you have done in the earlier sums. So here let x equal to 2.93 bar, so that can be written as 2.9393. Okay, so give this as equation 1. Now you see how many digits are under the bar? 2 digits are under the bar. Since 2 digits are under the bar, you will be multiplying both sides with 100. Okay, so this will come out to be 100x, and here what will happen? 100 into 2.9393. Now since 2.9393, so 93 will come before the decimal, because since 2 zeros are there, you are multiplying 100 with 2.9393. So what will happen? 93 will be placed before the decimal. So 293.9393. So this will come as equation 2. So 2 minus 1, so 100x minus x equals to 293.9393 minus 2.9393. So this is 99x, and this will come as 291. Okay, so x equals to 291 by 99. Now you see whether it can be simplified further. Yes, it can be simplified further since both of them are divisible by 3. So 3 9s are 27, 27, 291, 3 9s are 27, 21, so 97, and this is 33. So 97 by 33 is the equivalent decimal expansion. Now the next sum is 18.48 bar. So here also you will be proceeding in the same procedure. So here we will write let x equal to 18.48 bar. So that can be written as 18.4848. Give this as equation 1. Now since two digits are under the bar, so what will you do? Multiplying both the sides with 100. So what will you get? 100x into 100 into 18.4848. Now as you are multiplying this decimal number with 100, means two zeros are there. So this 48 will come before the decimal. You know these things, right? You have done in your lower classes. So 1848.4848. Okay, so that give this as equation 2. So 2 minus 1, 100x minus x, 1848.4848 minus 18.4848. Now if you subtract this, let us subtract this 48. So this will be 0, this will be 0, this is 3, 1830. So 99x equals to 1830. So x is 1830 by 99. Now 1830 is divisible by 3 and 99 is also divisible by 3. So let's reduce it into smallest term. So 3 6 are 18, 610 33. So 610 by 33 is the equivalent decimal expansion. Now the next sum is 0.235 bar. So here you see 3 digits are under the bar. So let x equal to 0.235 bar. So this we will write as 235, 235. Okay, give this as equation 1. Now since 3 digits are under the bar, so to get rid of the decimal, what will be multiplying it with? Yes, we will be multiplying it with the number that has 3 zeros. So we will be multiplying it with 1000. So multiplying both sides with 1000. So this will come as 1000x, and this will be 0.235235 into 1000 will make 235 to come before the decimal. So 235.235235. So this as equation 2. So 2 minus 1, 1000x minus x equals to 235.235 minus 0.235235. So this comes as 999x equals to 235. Okay, so x equals to 235 by 999. The next sum is 0.0032 bar, means under 32 there is a bar. Okay, so let x equal to 0.0032 bar, that is 32 will be repeating. Okay, so here since 2 digits are under the bar, so multiplying both sides by 100, so you get 100x equals to what? 100 into 0.003232, so 100x equals to, now this 00 will come before the decimal, so 00.3232. okay, so this is equation 2. So 2 minus 1. 2 minus 1 will give us 100x minus x equals to 0.3232 minus 0.003232. So you see, so what you are getting? 3, 2, rest of them are 0. So this is x equal 99x equal to 0.32. Now you see, here also, here you are left with the decimal 0.32. Now you want to get rid of the decimal. You have got rid of the recurring terms, but you here decimal is there. So to get rid of the decimal, 0.32 by 99. So to get rid of this decimal, what will you do? If we multiply it with 100, then the decimal, you can remove the decimal. So just multiplying both the both numerator and denominator with 100. So what will you get? 32 divided by 9900. Okay, so this can be reduced, you can reduce it, so this will come as 216, and this one is 4950. If you do the division, you will get 2 8s are 16, again it is divisible by 2, and this will give us 2475. So 8 divided by 2475 is the equivalent fraction for this. The next sum is 1.323 bar. Okay, so here if you notice carefully, 23 is under the bar. So let x equal to 1.323 bar. Okay, so this can be written as 1.3232323 equation 1. So multiplying both sides with what? With what will you multiply? Since only 2 digits are under the bar, you will be multiplying it with 100. So this is 100x. So 100 into 1.3232323. So this will come as 100x. So 32 will come before the decimal. So 132.323232. Okay. So here if you subtract 2 minus 1, so 100x minus x, so you will be getting as 132.3232 minus 1.3232. So you are getting this is 99x 131. So x equals to 131 by 99 is the equivalent decimal expansion. The next sum is 0.3178 bar. So 178 is under the bar. So let x equal to 0.3178 bar. So that can be written as 0.3178178 in this way. Okay. So here you see, since 3 digits are under the bar, so what will you be multiplying with? You will be multiplying it with 1000. So multiplying, give this as equation 1. So multiplying both the sides with 1000. So this will become 1000x and 1000 into 0.3178178. Okay. Now since you are multiplying this number with 1000, so 3 digits will come before the decimal. So what are the 3 digits? 317 will come before the decimal. So the number will become as 317.8178. Okay. Now what to do? Now you give this as equation 2. 2 minus 1. 1000x minus x, 317.8178 minus 0.3178 178. Write in this way. After that we will see how to subtract. After subtraction, what will be the value? 3178. Okay. So this 0, 0, 0, this is 5 point. So you are getting 317.5. So 999x equals to 317.5. So x will become 317.5 divided by 999. Now though this expression has become free of the recurring decimal part, but still there is a decimal associated with the number. So to get rid of the decimal and to get the number in the form of p by q, what you will do? Since 0.5, since only one digit is after the decimal, so to get rid of the decimal, we will multiply both the numerator and the denominator with 10. So if what are you getting? 3175 divided by 9990. Okay. Now either you can keep in this way or you can reduce it to simple terms. Okay. So after reducing, what will you get? 3175 is divisible by 5. So 3175, 5 6 are 30, 1 7, 5 3 are 15. So 25, 635, okay, 635 and 5 9 triple 90, 5 ones are 5, 49, 5 nines are 45, 9 40 again 49, 5 nines are 1998. So 635 divided by 1998 is the answer. The next sum is 32.1235. So here if you see, only 35 is under the decimal, is under the bar. So let x equal to 32.123535. Give this as equation 1. So 2 digits are under the bar. So multiplying both the sides by 100 with 100. So 100x 32.123535 into 100. So this will become, 2 digits will come before the decimal. So this will be 3212.3535. Okay. So this is equation 2. So 2 minus 1. So this will become 100x minus x. So 3212.3535 minus 32.123535. Let's see. Let's subtract it. This is 0, 0, 3, 2. This is 0, 8, 1, 3. 3180.23. So 99x equals to 3180.23. Now here a decimal, after decimal some numbers are there. So to get rid of the decimal, first of all write in this way, divided by 99. Now you multiply both the sides with 100, since only 2 digits are after the decimal. So to get rid of the decimal, we are multiplying it with 100. So the number becomes 318023 divided by 9900. Okay, so either you can keep in this way or you can reduce it to simpler terms. It is up to you. No, you can't reduce it further, so better you keep in this way. Now the next equation is, problem is 0.407 bar. So 7 is under the bar. So let's write, let x equal to 0.407 bar. So that can be written as 0.40777. Give this as equation 1. So multiplying both sides with 10, since only 1 digit is under the bar. So 10x equal to 10 into 0.40777. So 4.0777. Okay. So this is equation 2. 2 minus 1 will give us 10x minus x. 4.0777 minus 0.40777. Let's perform the subtraction. So you are ultimately getting 9x equal to 3.67. So let's get rid of the decimal. 3.67 by 9. So to get rid of the decimal, that is 0.67, you are to multiply it with 100 in both the numerator and denominator by 100. So you are getting 367 by 900. The next type of sum is express 2.36 bar plus 0.23 bar as a fraction in simplest form. Means both of them are in the recurring decimal form, that is non-terminating and repeating decimal form, and so both of them plus adding it, you are to show it in the form of a fraction. So first of all, to express it in the form of a fraction, first of all you have to get rid of the decimal, obviously. So let's try to tackle it individually. Means let us try to express 2.36 in P by Q form and 0.23 also in the P by Q form, and the ones that we get, both the fractions that we will get, that we will add it together and get the result. Okay, so first of all, let us find out the equivalent fraction for 2.36 bar. Okay, so solution, let x equal to 2.36 bar. Okay, so that can be written as 2.3636, equation 1. So since 2 digits are under the bar, multiplying both sides with 100, we get 100x equals to 236.3636. You know the drill, that is 2 digits will come before the decimal. So this is equation 2. Okay, so equation 2, so 2 minus 1 will give us 100x minus x equals to 236.3636 minus 2.3636, that is 99x, and this comes as 234. Okay, so let's keep it to x equals to 234 by 99. Okay, so 2.36 bar we have converted into equivalent fraction. Now let's come to this part. Okay, so again let us consider, let y equals to 0.23 bar. So that can be written as 0.2323, equation 3. Okay, so since 2 digits are under the bar, so multiplying both sides with 100, so this becomes 100y equals to 23.2323. This is equation 4. So 4 minus 3, that is 100y minus y, 23.2323 minus 0.2323. So that comes as 99y equals to 23. So y equals to 23 by 99. So now we write the entire expression, 2.36 bar plus 0.23 bar. Now equivalent fraction for this is 234 by 99 plus for this is 23 by 99. Now take 99, the LCM is 99. So 234 plus 23. So that gives us exactly 257 by 99. So 257 by 99 is the equivalent fraction or P by Q form of this expression. The next sum is just the same as the previous one, expressed in the form of P by Q, 0.38 bar plus 1.27 bar. So here also let's tackle both the two decimal parts individually. So let x equals to 0.38 bar. So 0.38 bar, 0.3838 equation 1. Okay, so multiplying both sides with 100. So this is 100x, 38.3838 equation 2. Okay, so 2 minus 1, 100x minus x, 38.3838 minus 0.3838. So this comes as 99x equals to 38. So x comes as 38 by 99. So next is 1.27 bar. So let y equals to 1.27 bar. So that can be written as 1.2727. This is equation 3. Okay. So 2 digits are under the bar. So multiplying both sides with 100. So this becomes 100y, 127.2727. This is equation 4. So 4 minus 3, 100y minus y, 127.2727 minus 1.2727. So this is 99y and this is 126. So y equals to 126 by 99. Okay, now we write the entire expression 0.38 bar plus 1.27 bar. So the equivalent P by Q form for 0.38 is 38 by 99 plus 1.27 bar is 126 by 99. So if you take the LCM, so this comes as 164 by 99. Okay, now one shortcut I will tell you for this type of sum is that, like if the number is there is no other digit before the decimal, like here 0.38 bar, so there is no number before the decimal, right? No other than 0. Okay, so if this is the case, so without performing the entire calculation, you can simply tell what will be the equivalent P by Q form. Like here, since 2 digits are under the bar, so just write down 38 and as the numerator, and the denominator will be 99, because 100 minus 100x minus x will give you this 99. So 99. Like if it is asked 0.7, so what will you do? You will write 7 as the numerator, and the denominator will be, since only one digit is under the bar, so we will write 7 by 9. So if I tell you 0.339, if it is there, so write down the numerator as it is 339 and the denominator will be 999. So this is one of the simplest way. Without doing the actual calculation, you can find out. So this is the end of this chapter. I have solved all the example, all the problems present in the exercise. So it's up to you to practice those sums, to see if there is any confusion or not, and do let me a comment in the comment section. Okay, so I'm signing off now. So if you like the video, please subscribe to Learn Guru classes, like, share and subscribe. Okay, so thank you so much. Bye bye.